Have you ever gazed at the night sky and wondered just how big the universe really is? Our journey begins right here on Earth, the blue and green cradle of life, our cosmic home. As we set off on our voyage, we look towards the sky at our closest cosmic neighbor, the moon. It's easy to think of the moon as just a step away, but let's put that into perspective. Imagine you could drive straight up at an average speed of 60 miles per hour. To reach the moon, you'd need to keep going for over 6 months without stopping for a break. If you opted to travel by plane instead, flying at an average speed of 550 miles per hour, it would still take you 2 weeks to touch down on the lunar surface. Now consider this. The time it would take to drive to the moon is about the same as driving around the Earth. 200 times. But the moon is closer than you may think. In fact, all the planets in our solar system could fit in the space between Earth and our lunar companion. And yet, the moon is merely a stone's throw away in cosmic terms. It's our immediate neighbor in a neighborhood that stretches billions of miles across. It's like standing at the door of your house looking down your street and realizing that the next house over isn't just a few steps away, but a journey of epic proportions. Our Earth, this moon, they are both tiny specks in the grand theater of the cosmos, dwarfed by the vastness of space and time, but they are our specks, our starting points in the quest to understand the universe. We're about to embark on a journey, a grand tour of the cosmos. We'll travel from our home past the moon and the stars all the way to the very edges of what we can observe. Yet the moon is just our first stop in this grand cosmic journey. Venture further than the moon. You'll find our sun, a glowing milestone in our cosmic neighborhood. This fiery sphere is not just our light and life source, but it's also a critical marker in understanding our place in the cosmos. It's about 400 times the moon's distance from us. Moving beyond the sun, we encounter Mars, the red planet. This celestial body, home to the largest volcano and canyon in our solar system, is a staggering 200,000 times farther from us than our moon. To put it in perspective, if we were to take a trip around the Earth at the equator, we would have to do it more than 7 million times to cover the distance between Earth and Mars. From Mars, we journey to Neptune, the most distant planet in our solar system. The distance from Earth to Neptune is so vast that it's about 2.5 million times the distance from Earth to the moon. That's like circling the Earth more than 100 million times. As we approach the outer reaches of our solar system, we encounter the Oort cloud, a region filled with icy bodies and the birthplace of many comets. It begins at a distance that's 50,000 times farther than the moon. If we were to travel around the Earth, we'd have to do it over 2 billion times to match this distance. Finally, let's consider our nearest star system, Alpha Centauri, which is about 25 trillion miles away. That's a number so vast that it's almost incomprehensible. If you could fly an airplane to Alpha Centauri, even at a speed of 600 miles per hour, it would take you over 40 million years to get there. From here we can only press onward to the boundaries of our solar system and beyond. Beyond our solar system, we travel to the Voyager 1 probe, the Oort cloud and the neighboring star system of Alpha Centauri. With these landmarks behind us, we find ourselves in the cosmic wilderness of the Milky Way, our galactic home. The Milky Way, a barred spiral galaxy, is an immense cosmic structure made of stars, gas, and dust, all bound together by gravity. It's so vast, in fact, that light, traveling at a staggering 186,000 miles per second, takes about 100,000 years to traverse from one side to the other. Imagine that for a moment. A beam of light, unimpeded and traveling at the fastest speed known to us, still needs 100,000 years to cross our galaxy. Our solar system resides in one of the spiral arms of the Milky Way, specifically in the Orion arm, some 26,000 light-years away from the galactic center. We are, in essence, cosmic suburbanites living in the quieter outskirts of a bustling galactic city teeming with stars. But how do we fit into this picture? If we were to represent the Milky Way as the United States, then our solar system, including the vast space between the Sun and Neptune, would fit into a coffee cup. And Earth? Earth would be smaller than a grain of sand within that cup. It's a humbling perspective, reminding us of our tiny, yet precious place in the cosmos. Yet, the Milky Way is not alone. It's one among hundreds of billions of galaxies strewn across the universe, each with its own collection of stars, planets, and potential life-bearing worlds. And the distances between these galaxies are mind-boggling, measured not in thousands or millions, but billions of light-years. But even the Milky Way is just a speck in the grand cosmic scale. As we continue our journey, we'll venture beyond the confines of our galaxy, into the vast expanse of the universe, where superclusters of galaxies await. Leaving the Milky Way behind, we find ourselves in the local group, Virgo Supercluster, and the staggering Laniakea Supercluster. The local group, our cosmic neighborhood, is home to more than 50 galaxies, including our own. It's a pocket of space spanning roughly 10 million light-years. To put that into perspective, light, which travels at approximately 186,000 miles per second, would take 10 million years to cross the local group. Beyond the local group, we venture into the Virgo Supercluster, a colossal structure of over 1,000 galaxies. It's about 110 million light-years in diameter. If we were to travel at the speed of light, it would take us 110 million years to cross it from end to end. But the grandness of the universe doesn't stop there. We are part of an even more massive structure, the Laniakea Supercluster. This cosmic titan encompasses 100,000 galaxies and stretches 500 million light-years across. The sheer scale of this supercluster is awe-inspiring and humbling. Within the Laniakea Supercluster, there is a point known as the Great Attractor, a gravitational anomaly that pulls galaxies towards it. It's a testament to the immense forces at work in our universe. The distances and sizes we're discussing here are almost incomprehensible. The light we see from these distant galaxies left their stars millions, even billions of years ago. We're not just looking into space, we're looking back in time. These superclusters and the Great Attractor are not just distant objects, they are part of our cosmic journey. Their vastness and complexity are a reminder of our small but significant place in the cosmos. Yet even these colossal structures are just stepping stones in our journey. We're about to confront the boundaries of the observable universe and ponder the mystery of what lies beyond. So buckle up, the journey is about to get even more fascinating. Finally, we confront the boundaries of the observable universe, a sphere 93 billion light-years in diameter. Imagine, if you will, a cosmic balloon expanding in all directions, with us at the center. This is the observable universe, and it's all we can see from our vantage point here on Earth. Now, let's try to comprehend this enormous scale. Picture the Earth, a tiny speck within the vastness of the solar system. Now imagine the solar system as just a grain of sand within the expanse of the Milky Way. But it doesn't stop there. The Milky Way is but a small town in a country of galaxies we call the Laniakea Supercluster. Yet even this supercluster is a mere dot within the observable universe. Such is the scale we're dealing with. But what lies beyond this cosmic sphere of visibility? It's a question that has fascinated astronomers for centuries. The truth is, we don't know. What we do know is that the universe is much larger, perhaps even infinite. But due to the finite speed of light and the age of the universe, we can only observe a fraction of it. Consider this, the light we see from distant galaxies left them billions of years ago. In fact, the oldest light we can see, the cosmic microwave background radiation, has been traveling for almost 14 billion years. This ancient light is a snapshot of the universe shortly after the Big Bang, providing a cosmic boundary to our observable universe. So, as we journey through this cosmic expanse, we realize we're not just traveling through space, but also time. Our telescopes are like time machines, allowing us to glimpse the ancient universe, to see galaxies as they were billions of years ago. As we gaze into the vast cosmic sea, we can only marvel at our humble place within it. We are but tiny observers in a universe that is vastly larger and older than we can possibly comprehend. Yet, it's a universe that we're a part of, a universe that we're just beginning to understand.